Okay, so yesterday we learned how to find the horizontal, vertical, and holes for a graph. So today we're going to graph them. So we know that there's an NPV at x equals -2. Is that a hole or a vertical asymptote? So plug it in. What do you get? You get a number divided by 0, which gives me a vertical asymptote. So I know my vertical asymptote is at x equals -2. The other thing that we figured out is that the leading coefficients, if they're the same degree, if you divide that, that gives you your horizontal asymptote. Again, if you don't understand that, you can actually do long division and go x plus 2 goes into 2x minus 6 twice, and you get 2x plus 4, subtract, so we get -10. So this is rewritten as -10 over x plus 2 plus 2. And you can see that is my k value. That is my a over x minus h. And my vertical asymptote is in fact -2, and my horizontal is shifted up 2. So we're going to do that. We're going to do that. And we need to find one point in each section to see. So sometimes the y-intercept and the x-intercept helps. Sub x to 0. It just ends up being the the constants divided. So that means we get -3. So put that on the graph. If you want to find the x-intercept, set y to 0, which means, that gets cross-multiplied over, and you only have the numerator to look at. Move the 6 over, divide by 2, I get 3. So I know it's like this, and you just have to hug the asymptotes. Pick a point that's in the other quadrant. I'm going to sub in -4 and see what I get. So when x is -4, I get -8 minus 6, which is -14. -4 plus 2 is -2, so I get 7. So like that, and then again hug it. So I'm going to do the domain, maybe not interval notation. I'm just going to go x is an element of the reals. X cannot equal -2 today. And the range y is an element of reals. Y cannot equal +2. Just much easier than interval notation right now. Okay. Let's move on. When you have a bigger degree on the top than the bottom, we need to divide. So let's try to factor first. So that is x minus 2 times x minus 3 divided by x minus 2. Those will cancel, and we're left with x minus 3, where x cannot equal +2. So what's going on here? We have a line with a hole. So my hole is going to be at 2. How do I find the coordinates of the hole? Plug it into the simplified version. 2 minus 3 is -1. So do we have a horizontal? Well, no, it's a line. We only have a horizontal when we have a bigger degree on the bottom than the top. When we have a bigger degree on the top, we could have a potential to have an oblique asymptote like we saw yesterday, but this isn't the case. The non-permissible value is 2. But when we sub 2 in, we get 0 over 0, so we do not have a vertical asymptote. The y-intercept would be -3 if I just sub in 0. My x-intercept is, if I look at the simplified version and sub y is 0 and solve, I get +3. So 3, -3, a hole at that. There we go. There we go. So what's my domain? X is an element of the reals. X cannot equal 2. Y is an element of the reals. Y cannot equal -1. So here's a case where the degree on the bottom is bigger, so we have a vertical asymptote. If I put in a huge number, you'll see that I get a number divided by a huge number, which means I will get a horizontal at y equals 0. If I factor the bottom, I get x minus 4 times x plus 4, which gives me vertical asymptotes at x equals plus or minus 4. If I sub 0 in for the y and solve for the x, I get 0. Same if I get that. There's no holes here, but let's start graphing this and see what happens. Now, again, I caution you not to make y equals 0 throughout the whole thing. This is just far rights and lefts. Then we have a vertical at 4 and negative 4. So we're going to have 3 sections here, and this is why, again, I'm cautioning you doing a horizontal through the whole thing, because you're going to see in a second when I put the x-intercept or the y-intercept, it's going to go through there. So it's not actually going through the whole entire graph here, far lefts, far rights. Okay, so we need to have a point that's in the right section. So I'm going to get when x equals 5, just because that's on the right of 4. So that means y equals 5 divided by 25 minus 16, which is 5 divided by 9. So that means it's positive, and it's going to go like that. When x equals negative 5 on the far left, I'll get the same thing, but this time it's going to be negative 5 over 9. So like that. Now we just need to figure out what's going on between 0 and the vertical asymptotes. So let's pick when x equals negative 1. I plug that in. I get y equals negative 1 divided by 1 minus 16. Gives me negative 1 over negative 15, which gives me positive 1/15. So it's above the line. And let's see what's going on when x is 1. I get y equals 1 over 1 minus 16. Gives me negative 1/15, which means it's below. So it's hugging it, then it's crossing and coming back. So what's my domain? My domain is x is an element of reals. X cannot equal negative 4 and positive 4. And now here is where the range is tricky, because at first glance you think, oh, there's a horizontal asymptote, so y can't be 0. But if you look at the middle section, it clearly shows that the range can be anything. So y is an element of reals. Okay, moving on here. So when the degree is the same on top as the bottom, that's when we have a shifting of the horizontal asymptote. Again, if you divide that, we get y equals 1. So again, far left. In this case, you might want to do it the whole thing just so you can see what's going on. Just be cautionary there. If I factor the bottom, I get x minus 1 and an x squared. Ooh, that means I can cancel one of these x's, and I get y equals x over x minus 1, where x cannot equal. Now, if I cancel out an x, what does x cannot equal? 0. So what's happening at 0? That's a hole. At 0, plug it back in. What do I get? 0. So I have a hole at 0, 0. A y-intercept potentially could be at 0, 0, but because there's a hole, it would be none. And we have a vertical asymptote because we still have a non-permissible at x equals 1. So x-intercept none. Now we need to, I can see that this is going to go like this. I need to get another point. It looks like the point will be mirrored over here, but do yourself a favor and maybe just plug in 2 and verify that you get 2, 2. So when x equals 2, y equals 4 divided by 4 minus 2. 4 divided by 2 is 2. So my domain is x is an element of reals. X cannot equal, well, x can't equal 0 and 1. My range, y is an element of reals. What can y not equal? Looks like it's not equal to 1 at all. So y cannot equal 1. All right. So now we're going to actually come up with equations. The equations are kind of, you know, loosely done. They're looking for main characteristics here. We need to have a horizontal asymptote at y equals 0, which means that we need to have a bigger denominator at the bottom than the top. So let's just look at the vertical asymptotes right now. We have a vertical asymptote at x equals 1, 2, 3, 4, negative 4, and x equals 1, 2. So that's represented by x plus 4 times x minus 2. Normally we just put an x on here to have a bigger denominator. However, we have an x-intercept here of negative 1, and the only way that can happen is if we put the numerator equal to the x-intercept. So if it's x is negative 1, we need to put plus 1 and see if that works. Okay, so now verify that you're going to get the regions you're going to get. So for instance, when x is 1, 2, 3, we get it in the positive region. When x is, say, negative 5, we get in the negative region. So we're not going to worry about the constant too much. This is all they're looking for, essentially. So we do have a hole here for the next one at 1, 2, 3, 1, 2, 3. So that is at negative 3, 3. So when we write this, we need to have the same factor on the top as the bottom, which would be x plus 3 over x plus 3. We also have a vertical asymptote at x equals negative 2, which represents as x plus 2. Okay, so now in order to have a horizontal asymptote that got shifted up, we need to have an additional x on there. So here's the thing. We need to be able to get the whole to substitute to get that. So how do we do that? Well, the whole is at negative 3, 3. So if we end up canceling the x plus 3 and we plug that in, do we get negative 3, 3? So let's check. So y equals x over x plus 2, where x cannot equal negative 3. If I plug the negative 3 in, I get y equals negative 3 divided by negative 1, which gives me 3. So that checks. So we're all good. Okay, this one is kind of nice because you can kind of cheat on this one and say, does anybody know what the equation of this line is? Y equals 7, x can't equal, what is that, negative 2 and negative 6. And that would be a correct answer. However, if you wanted to write it as a rational, then you would write it as y equals 7, and then this would be x plus 6 over x plus 6, and then x plus 2 over x plus 2. Either would be acceptable answer. Again, this one's a nice one where you can have an easy, if you know what the equation of this line is, this is 1 to y-intercept of 3 and a slope of 1. So y equals x plus 3. X cannot equal 1, 2, 3, negative 4. As easy as that. Or you can write this as the rational, which would then be, you have to have the x plus 3 to get the line. And then you need to have, oh, there's another hole there I just missed. It was at 6, right? So that would represent x minus 6 over x minus 6 and x plus 4 over x plus 4. I'm circling that, but it's either answer.